All right. Woo. Hello, everyone, and welcome to AWS reInvent. Yeah. Woo. Thank you so much for joining us. It is great to be back here with all of you at our 11th reInvent. And I'm happy to welcome over 50,000 customers and partners here in Las Vegas, and over 300,000 attendees registered virtually around the world. It's amazing. Whether this is your first time at reInvent or your 11th, how many 11s out there? All right. How about your first? How about ones? For ones? All right. Well, whatever the number, I hope you'll take advantage of the incredible learning that's here this week, from attending your choice of over 2,300 different sessions to connecting with partners at the expo or meeting other members of the AWS community. There really is no other show like it. And we've got so much innovation to share here this week. We started the announcements on Sunday, and the excitement's going to continue. From Peter's infrastructure talk last night, we've got Swami on data tomorrow, Ruba at the partner keynote tomorrow as well, and then, of course, Werner to cap off the week on Thursday. And there's plenty to come in this 2 hours. By far, the majority of the innovation is driven by listening to and responding to you, to customers. And today, customers span every industry, every geography, and every use case. And as you keep proving, there is no challenge too big. The BMW Group is revolutionizing the driving experience with its connected car platform. Riot Games, publisher of the most popular PC games in the world, is now processing roughly 500,000 events per second to continually improve its games. And Privatbank, the largest bank in Ukraine, serving 40% of the population. Under the specter of war, they've managed to move all of their operations to the cloud, 330 IT systems and 4 petabytes of customer data to AWS in just 45 days, safeguarding customers' ability to keep banking. Things that people said never could be done, like bringing capital markets to the cloud, they're happening now. On this stage, right here, last year, NASDAQ CEO Adena Friedman announced that they would move their matching engine to AWS. Now, that's the technology that makes the markets tick by changing an order into a trade. And it's the foundation of the infrastructure for the world's capital markets. These workloads are incredibly latency sensitive, they're security sensitive, and Adena said they'd start by bringing their first market to the cloud in 2022. Big goal, big claim. And guess what? They're almost done moving the first of the North American options markets. They moved a number of symbols already, with the rest on track to move before the end of this year. And customers are already seeing enhanced performance. Now, it's not just large organizations. According to PitchBook, there are more than 1,000 unicorn startups in the world, and the majority, 83%, run on AWS. And more than 90% of the startups on the Cloud 100 also run their businesses on AWS. These include successful unicorn startups like 6sense, Wiz, and DataRobot. These leaders could choose any cloud provider, and they choose AWS. We're also taking a leading stance in sustainability. Personally, to me, I think it's the issue of our generation. And Amazon is now the world's largest corporate purchaser of renewable energy. We're committed to powering our operations with 100% renewable energy by 2025, and we're already on target and over 85% of the way there. And we're also investing to... Please, everyone, get involved. It's a problem for all of us. And we're also innovating to improve our water use efficiency. And we're leading amongst cloud provider with an efficiency metric of 0.25 liters of water consumed per kilowatt hour in our data centers. And as we announced Sunday, we're committing to becoming water positive by 2030. That means we will return more water to our communities than we use in direct operations. Very excited about that. We're building sustainability into everything we do, and that includes working with you. We're determined to be inventive and relentless as we work to make the cloud the cleanest and the most energy-efficient way to run all of your infrastructure and your businesses. Because we have the largest community of customers and partners, we have the opportunity to see more business challenges, more new ways of looking at problems, and also the global impacts of regulation and emerging trends. Of course, I want to acknowledge that there's a lot of real and pressing problems and challenges in the world right now. The economic uncertainty rippling around the world, inflation, supply chain disruption, including chip shortages, energy prices, and of course, war. All on top of a global pandemic that's impacted so many. In times of uncertainty, it actually can be tempting to cut back, slow down. But when it comes to the cloud, many of our customers know that they should be leaning in precisely because of economic uncertainty, not despite it. The cloud is more cost-effective, and many customers are saving 30% or more. For example, Carrier Global is a Fortune 500 company, and they've seen a 40% reduction in the cost of running its mission-critical ERP systems. Gilead estimates that it will be saving more than $60 million within 5 years through a lot of strategic cloud adoption initiatives. And AGCO is an agricultural manufacturer and another Fortune 500 company. They've reduced their costs by 78%, while at the same time increasing data retrieval speed. If you're looking to tighten your belt, the cloud is the place to do it. Another critical capability, now more than ever, is flexibility. It's hard to plan in this environment, but with AWS, you don't have to worry about having too much or too little capacity. You can easily scale up and scale down as needed, and paying only for what you use. This benefits your expenses and, of course, your ability to serve customers. In 2019, Airbnb was already a significant cloud user. And with all of their expertise in the cloud and the efficiencies that they had already captured, they were far more prepared than many others when the bottom fell out of the hospitality industry in 2020. Airbnb was able to take down their cloud spending by 27% quickly. And then, when the world began to emerge from the worst of the pandemic, Airbnb was able to quickly turn on the cloud infrastructure that they needed and continuing to drive innovation. And you still do need to innovate, especially now. You want to develop new ways to operate efficiently and serve customers better. And the cloud helps you do this faster and cost-effectively. You can be agile with fewer resources. One study found that by migrating on-premises workloads to AWS, customers reduced time to market for new features by 43%, with many customers achieving over 60% savings in time to market. What this means is that you want to be ready for anything, for operating efficiently, for flexible responses to unexpected circumstances, and for innovating. The cloud gives you this capability, operating efficiently in lean times, and being stronger than your competition, ready to accelerate when business conditions change. One thing that's always amazed me about our customers is the way that you continue to innovate and accomplish incredible things. Even in uncertain times, innovation is critical. Learning to navigate new environments, exploring. Growing up, I loved reading about great adventures, stories of expeditions into the unknown. And this is something I've been thinking about a lot as I've been looking at the challenges facing all of us. I realized that looking at how we explore can teach us valuable lessons for today's uncertain environment. Some environments are vast. Some are unfathomable. Some are extreme. And some are bursting with possibilities. But with the right tools, you can survive, even thrive, in any of these environments. So let's take a look today at some of these remarkable explorations, past and present, and what they can teach us. Let's start with one environment that we've been exploring for centuries and yet have really only just begun to grasp. Humankind has always been fascinated with the stars above. Looking up on a clear night, it can almost feel as though the answers to our most enduring questions are twinkling back at us. How did all of this start? What else is out there? One of the biggest obstacles to exploring these answers is the sheer immensity of the universe. With just your naked eye and the right conditions, you can see to the edge of our galaxy. And that's 2.5 million light years. Then in 1609, Galileo picked up the newly developed spyglass, tinkered with it to increase magnification by 10x, and exploded the boundaries of what humans could perceive. The description of vast was suddenly so much bigger. But to really begin to explore that vastness, we had to find a way to get past the obscuring layer of the Earth's atmosphere. It took centuries to enter the rocket age, and then we put telescopes into space itself. Now we could truly begin to tackle the magnitude of space. And current rough estimates of this magnitude suggest that there are 1 septillion stars. So it's probably not a surprise that they're not all the same. Some emit light at wavelengths along the electromagnetic spectrum, most of which are completely invisible to our eyes. If we only use one telescope tuned to one spectrum of light, we risk missing out on the full picture. So let's take a look at one famous space image to see what I mean. In 2014, the Hubble telescope captured this. The pillars of creation, clouds of dust and gas that are 5.8 billion miles across, forming the iconic hand shape. So this view captures the light inside of the visible spectrum. Now let's look at it in literally a new light. Near-infrared light, captured by the James Webb Telescope earlier this year. This image is not only filled with stars that we couldn't perceive before, it also allows us to see through the obscuring clouds to reveal baby stars actually forming within the pillars. But there's more. Just last month, NASA released the pillars of creation in mid-infrared spectrum. Completely different light. The stars almost entirely disappear, and the clouds of dust become the focus. This new view is helping scientists to better understand the key ingredients for the formation of new stars. Now, this is just one section of a single nebula viewed at only 3 different light wavelengths. Multiply that complexity across billions of galaxies, and you can just begin to imagine how many different tools we're going to need to try and explore across the breadth of our universe. And so we continue to innovate new ways to explore and understand the vast realm of space. We've sent rockets and rovers, satellites and space stations, launched on missions from hundreds to millions of miles away from Earth. Now, most of us aren't astronomers, but we do face the challenge of gaining understanding from another vast and challenging realm, one that also requires stitching together insights from different systems and teams to put together the full picture, and one that tantalizes us with the promise of the answers that we could get, the insights we could achieve that could propel us forward if only we could harness them. I'm talking about data. It's almost impossible to comprehend how much data there is, but just as remarkable is how fast it's growing. Analysts predict that in the next 5 years, we're going to create more than double the amount of data produced since the dawn of the digital age. Managing the scale and the growth of that data is both a huge challenge and an opportunity for every organization. So what does this look like in terms of what customers are actually doing? Let's look at a couple examples. The Expedia Group processes over 600 billion AI predictions per year, powered by 70 petabytes of data. Samsung's 1.1 billion users make 80,000 requests per second. Pinterest stores an exabyte. That's 1 million terabytes of data on S3. These are just a few examples, but they all have one thing in common. Data is at the center of applications, of processes, of business decisions, and is the cornerstone of almost every organization's digital transformation. But working with data is tricky. Just as the vastness and complexity of space means you can't explore it with just one technology, the same is true for data. You need a complete set of tools that accounts for the scale and the variety of this data and the many purposes for which you want to use it. You need to integrate and combine all that data that's spread across so many different places to create a better understanding of what's happening and predict what will happen. You need governance so that your teams can explore and innovate while always making sure that your data is safe and secure. And you need to be able to visualize data in a way that makes it fast and easy to discover and share insights. You need to do all of these things to explore the vastness and complexity of your data and to generate insights for your business. So let's talk about these tools. So AWS is focused on building out all of these capabilities to help you explore your data. And since virtually all applications have a database, let's start there. We have the broadest selection of databases you'll find, with 8 purpose-built non-relational databases and 5 relational data engines, including Amazon Aurora. Aurora is our MySQL and PostgreSQL-compatible relational database built for the cloud. It's the fastest-growing service in the history of AWS, and hundreds of thousands of AWS customers use Aurora. It combines the performance and availability of traditional databases with the simplicity and the cost-effectiveness of open-source databases. Aurora has 5 times the performance of standard MySQL and 3 times the performance of standard PostgreSQL, and it's 1/10 the cost of commercial databases. Now, data from your applications can be stored many different places, but of course the data is diverse, it's complex, and it comes from a lot of different sources. So you need the right analytics tools in order to analyze all the different types of data you have. And you want these analytics services to offer the best price performances for all data types and all use cases. And we have the broadest and the deepest set of analytics services, so you never have to compromise on cost, on performance, or on scale. If you want to do large-scale data processing using open-source distributed frameworks like Spark, Hive, or Presto, you can use EMR. If you want to do real-time processing of streaming data, you can use Amazon Managed Streaming for Apache Kafka. And if you have structured data where you need super fast querying results, we have Redshift. Redshift is our fully managed petabyte-scale data warehouse, and tens of thousands of AWS customers use Redshift every day to store and analyze exabytes of data. It delivers up to 5 times better price performance than other cloud data warehouses. Last year, I announced Serverless for Redshift. Adoption has been incredible, and today there are already thousands of customers using Redshift Serverless every month. And they don't have to worry about configuring, scaling, or managing clusters or servers. They don't have to worry about provisioning capacity. With just a few clicks, you can create a Redshift serverless endpoint, and it automatically scales in seconds, and then it scales right back down when not busy. And customers only pay when the service is in use. Now, you may have noticed from the previous slide, if you're paying very close attention, that one of the analytics services is not like the others. Most have serverless options. But we have a single analytics service that doesn't yet have a serverless option. And many of you have been asking us, when can we get a serverless option for OpenSearch? Well, that time is now. And today we're announcing the preview of OpenSearch Serverless. You can use this platform to perform interactive analytics, real-time application monitoring, website search, and more without having to worry about provisioning, configuring, and scaling infrastructure. Now we have serverless options for all of our analytics services, and no one else can say that. So analytics helps us understand what's going on today. Machine learning allows us to predict what will happen in the future and also to build intelligence into systems and applications. Now, this is why we have the most complete set of machine learning and AI services. For expert practitioners, we have support for the most powerful and popular deep learning frameworks so that customers can run those themselves. And to make it easy for everyday developers to build, train, tune, and deploy machine learning models, we have SageMaker. And for developers who are less technical or other practitioners who don't want to muck around building and training models, we have a range of AI services that makes it as easy as an API call. SageMaker is incredibly popular, so why don't we take a deeper look there? Today, tens of thousands of customers are using SageMaker to train models with billions of parameters to make more than 1 trillion predictions every month. SageMaker makes it easier to scale ML throughout your organization with tools that enable more people to innovate with ML, and it also includes SageMaker Studio, an IDE for data scientists, and SageMaker Canvas, a no-code interface for business analysts. And we're continuing to innovate here. I really encourage you to tune in to Swami's keynote tomorrow to learn more about what we're doing with machine learning. There's going to be a lot of exciting news to share. So customers everywhere are eager to transform their organizations with the power of data. One customer on this journey is Engie, a global energy provider and one of the largest companies in France. Engie is focused on renewable and low-carbon distributed energy infrastructure, helping its clients to achieve a carbon-neutral future. To tell us more about how they're using data to power analytics and machine learning-driven insight, I'd like to welcome to the stage Biljana, Kaitović, Group Executive Vice President in charge of IT and Digital.
Thanks, Adam, and good morning, everybody. Everything we do it with energy. Everything I do it with energy. And today, I'm going to tell you a story. I will start it with a famous Serbian scientist to pay homage to my roots. In 1882, during a walk in Austria where he studied, Nikola Tesla came up with the idea of the alternating current motor. It is a key enabler of our daily use of energy, even today. That same year, the world's energy consumption was about 9,000 terawatt hours. It's roughly a third of what the US consumes today. Nowadays, the global annual energy consumption is 20 times higher, 180,000 terawatt hours. It's the amount of energy that could power the shiny city of Las Vegas for 5,000 years. And it does not stop there. The US Energy Information Administration predicts a further 50% increase by 2050. The world is very energy hungry, and it is becoming even more so. And this is not only a long-term challenge, but one we are facing today. We need energy to be affordable, accessible, secure, but above all, we need energy to be green. At Engie, our purpose is to accelerate the transition towards carbon-neutral economy. We're probably the first global energy company that has started this journey in 2015. It marks a significant chapter in the book of our 180-year history. In the old world, we had a relatively simple and centralized mix of energy supply, with sources like coal, oil, and natural gas. There was abundance of these resources, they were mostly affordable, and we didn't worry that much about burning fossil fuels. Today, we live in a different world. We're already witnessing severe weather events, forest fires, floods, droughts across geographies. We don't have much time to deal with this climate crisis. Every day counts. Our energy system is also becoming a lot more decentralized as we are shifting our mix to renewables and the main energy carrier to electricity. So why am I telling you all this? And why here at the AWS stage? It's because data and digital play a key role in this energy transition. And let me illustrate how with 3 examples. First, most renewable energies are intermittent by nature, as the sun does not always shine and the wind does not always blow. To optimize and forecast production levels of our renewables, we use a lot of data and advanced analytics. For predicting equipment failure before it occurs, we use predictive analytics, machine learning, and, of course, the Internet of Things. Second example, as we decentralize, we have an increase in small, local energy producers and consumers within so-called microgrids. You can think of the houses with solar panels on the roofs, or electric cars using their batteries to store energy. To balance supply and demand in this very complex system, we need to use a real-time energy management system. And to track sources and usages of energy, we can use blockchain. Third, let's switch from supply to demand. The best way to minimize the environmental impact is to reduce the energy consumption. At Engie, this is exactly what we do to help people and companies on that quest. And sometimes it is as simple as ensuring that HVAC and lighting are on only when people are present, for which, you can guess, the IoT plays a central role again. Now, you may wonder what a 180-year-old company has in common with a digitally native tech company like AWS. For a non-digitally native company like Engie, centralizing our data and ensuring its quality and availability was the first and key step on our cloud journey. Today, we have a common data hub where we store more than 1 petabyte of data across and use that across more than 1,000 projects. Our common data hub was built on Amazon S3, which provides the scalability, availability, security, and performance we need. We also use Amazon Redshift, allowing us to query semi-structured data and make use of analytics. We use many other AWS resources like Kinesis Data Streams, Glue, Athena, and SageMaker, which allows our developers and data scientists to train and deploy data machine learning modules with speed. They all help to make our clean energy more efficient. As an example, in the heating and cooling networks that we run for cities like Paris, Dubai, or Barcelona, these tools power our dedicated digital solution that help Barcelona, for example, to reduce this network's energy usage by up to 15%. And it's just a start. Additionally, we have experienced 60% savings on runtime in the cloud by automatically scaling up our infrastructure during working days and scaling it down during weekends and at nighttime, which, of course, helps us to save the precious energy. And that is exactly how the relationship between Engie and AWS creates a very exciting flywheel effect. AWS technology enables Engie to create digital platforms that help us to accelerate the energy transition. And Engie provides green electricity to AWS from our solar and wind farms in the UK, US, Italy, and France, helping Amazon to reach their goal of powering the operations with 100% electricity, which is renewable. So what does this all mean for you? As we all scale up our digital platforms and solutions, our digital real estate will continue to grow, and so will its energy usage. Therefore, it is imperative that we power it with green energy to ensure that we minimize its carbon footprint. If I close my eyes and peek into the future, I see a world in which everybody has access to the energy they need. Accessible, affordable, secure, and green. To get there, we need innovative solutions. But more than that, we need the best and the brightest. Today's Nikola Teslas of all genders and all backgrounds to make that a reality. We need everyone to play their part. So join us and let's work together to be at the right side of history. Because every day counts. Thank you.
Thanks so much, Biljana. It's a great example of everything that you're doing to transform something that's so important to all of us. Matters so much. Thanks so much for joining us.
Thank you for all the help.
AWS has all of these services across databases, analytics, and machine learning so that you can always have the right tool to explore the vastness and complexity of your data across your whole organization. But having all these tools to store and analyze data then reveals the next challenge that people face. Just like in space, you need to be able to combine information across these different methods of data exploration to see the full picture and truly gain insights. Maybe you have an online store and you want to offer an incentive to improve customer retention. You have application usage data in Aurora and customer reviews in your data lake. And this means you need to move both sets of data into SageMaker so that you can build a model that predicts when a customer might leave and offer the right incentive. Combining data from different data sources and different types of tools, that brings up a phrase that strikes dread into the hearts of even the sturdiest of data engineering teams. That's right, I'm talking about ETL, extract, transform, load. Just a few weeks ago, we got an email, a real email, from a customer discussing ETL, and they literally used this phrase, thankless, unsustainable, black hole. The manual effort, the complexity, and the undifferentiated heavy lifting involved in building ETL pipelines is painful. It requires writing a bunch of custom code, then you have to deploy and manage the infrastructure to make sure the pipeline scales. Still, it can be days before the data's ready, and all the while you've got an eager analyst pinging you again and again to check if their data is available. And when something changes, you get to do it all over again. We've been working for a few years now on building integrations between our services to make it easier to do analytics and machine learning without having to deal with the ETL muck. For instance, we have federated query capabilities in both Redshift and Athena so that you can run queries across a wide range of databases and data stores and even third-party applications and other clouds without moving any data. To make it easy for customers to enrich all their data, AWS Data Exchange seamlessly integrates with Redshift and enables you to access and combine third-party data sets with your own data in Redshift, no ETL required. And we've integrated SageMaker with Redshift and Aurora to enable anyone with SQL skills to operate machine learning models and make predictions also without having to move data around. These integrations eliminate the need to move data around for some important use cases. But what if we could do more? What if we could eliminate ETL entirely? That would be a world we would all love. This is our vision, what we're calling a Zero-ETL Future. And in this future, data integration is no longer a manual effort. One of the places where customers spend the most time building and managing ETL pipelines is between transactional databases and data warehouses. Let's say you run a global manufacturing company with factories in 15 different countries. You have an Aurora cluster storing order and inventory data in each of those countries. To get a real-time view of orders and inventory, you have to build individual data pipelines between each of these Aurora clusters to a central data warehouse to query across the combined data set. To do this, the data integration team has to write code to connect 15 different clusters and manage and test 15 different production pipelines. And once you've deployed them, you have to constantly monitor and scale them to optimize performance. And when anything changes, changes in 15 different places. It is monotonous and a lot of work, and we wanted to help. So today, I'm excited to announce the preview of a fully managed new Zero-ETL integration between Aurora and Redshift. This integration brings together transactional data with analytics capabilities, eliminating all of the work of building and managing custom data pipelines between Aurora and Redshift. It's incredibly easy. You just choose the Aurora tables containing the data that you want. In order to get that into Redshift, it appears within seconds. After it comes into Aurora, seconds later, the data is seamlessly made available inside of Redshift. And you can replicate data from multiple Aurora databases in the same Redshift instance. The data in Redshift is always consistent, and updates are automatically and continuously propagated. So you have the most recent information in near real time. And, of course, the entire system is serverless. It dynamically scales up and down based on the data volume, so there's no infrastructure to manage. Now you really have the best of both worlds. Fast, scalable transactions in Aurora, together with scalable analytics in Redshift, all in one seamless system. This newest integration helps solve one of the biggest ETL pain points for our customers. Now, this is great for running analysis in Redshift, but we also wanted to help customers doing analysis using Apache Spark, one of the most popular frameworks for processing data. We support Apache Spark in EMR, Glue, and SageMaker, with AWS optimized runtime that is fully optimized and 3 times faster than open source. Today, if you're working in EMR, you can use Spark to run analytics on data, say in your S3 data lake. But if you want to run a Spark query on data located in Redshift, you have to either move the data into S3 or find, download, and configure a slow open source connector to Redshift. A better way would be to just run a Spark query on the data right in Redshift. So we wanted to make this fast and seamless, and I'm really excited to introduce Amazon Redshift integration for Apache Spark. Now it's incredibly easy to run Apache Spark applications on Redshift data from AWS Analytics Services. You can use simple Spark jobs or Jupyter notebooks in AWS services like EMR, Glue, and SageMaker to connect to Redshift and to run read-write queries against Redshift tables. Now, no more need to move any data, no need to build or manage any connectors. Both Zero-ETL integration between Aurora and Redshift and the Redshift integration for Apache Spark make it easier to generate insights without having to build ETL pipelines or manually move data around. These are 2 more steps forward towards our Zero-ETL vision. We're going to keep on innovating here, finding new ways to make it easier for you to access and analyze data across all of your data stores. So we've talked about the vast scale and complexity of data and the need to run analytics and machine learning without the time and effort of moving the data around. But to unlock the full power, the full value of data, we need to make it easy for the right people and applications to find, access, and share the right data when they need it, and to keep data safe and secure with appropriate controls in place. You need governance. Finding the right balance between control and access is crucial, but it's different for every organization. Too much control, and your data ends up locked up in silos. People can't find what they need when they need it, and it stifles innovation and kills creativity. And they end up going around you, creating shadow IT systems that leave your data out of date, incomplete, and definitely unsecured. Too much access and your data ends up in places you don't want it to be. You need to make sure that your data is appropriately safeguarded. We believe that people are naturally curious and smart. We would never have ventured into space if that weren't the case. Establishing the right governance, one that lets you balance control and access, gives people within the organization trust and confidence. It encourages innovation rather than restricts it. But implementing data governance across an organization is complicated. You have all sorts of people with all sorts of different use cases and all sorts of data spread across multiple departments, services, databases, third-party applications, and more. You need to speak the language of all those teams across all those functions while still meeting your specific governance requirements. We know how absolutely critical this is to you. And so today, I am very happy to announce Amazon DataZone, a data management service that helps catalog, discover, share, and govern data across your organization. DataZone enables you to set data free throughout the organization safely by making it easy for admins and data stewards to manage and govern access to data. And it makes it easy for data engineers, data scientists, product managers, analysts, and other business users to discover, use, and collaborate around that data to drive insights for your businesses. It provides a web portal where data producers can set up DataZone business data catalogs. In your catalog, you can define the taxonomy or the business glossary. You can organize these terms and data sets based on your organizational hierarchies and business units. And then you connect DataZone to data sources, and it uses machine learning to collect and populate your catalog with the appropriate metadata. And you can add labels and descriptions to provide additional information, and then you just publish the catalog. Now, anyone wanting to access the data can search the catalog and discover data assets using familiar terms. They can examine the metadata and request access to the data by creating a new data project. Data projects define data sets and associated users. They bring together people, data, and analytics tools, making it easy to collaborate. All members of the project have access to both the data and the analytics tools they need, such as Redshift, Athena, QuickSight, to do data analysis. DataZone also provides APIs so that your team and partners such as Snowflake or Tableau can integrate with DataZone, enabling you to publish, search, and work with all of your data assets. Now you have an easy way to organize, discover, and collaborate on data across the company. There's really nothing else like it, and I'm really excited to see how you're going to use it. But the story doesn't end there. Once we've got good governance in place, we want to make it easy for people to explore and manage the data, and we want to make discovering and sharing data insights lightning fast. So QuickSight is our ML-powered business intelligence solution. You can easily create, publish, and embed interactive visualizations and dashboards. And we're continuing to innovate and add new capabilities to QuickSight. In just the last year, we've launched 80 new features and capabilities in QuickSight. And just yesterday, we announced print-friendly, highly formatted reports in QuickSight, which lets customers and business users create business-critical operational reports in the cloud. This is a big help for companies that are still using multiple reporting systems because of these formatting requirements. Now, one of the most popular capabilities of QuickSight is Q. Q is a whole new way of asking questions of your data. You might ask Q a question like, what are the top 10 products by sales in 2022? And Q will return the answer in the form of a visualization to you in seconds. Instead of you having to learn how the software works the way that you think. No SQL to write, no dashboards to create, no need to wait on a busy data science team to help. But what if Q were able to answer questions to help you understand what will happen in the future and why? That would be amazing. So today, I'm really happy to announce ML-powered forecasting with Q. With forecasting in Q, a business user looking at a dashboard can simply ask Q to forecast a metric into the future. For example, you could ask Q to forecast sales for the next 12 months and get an immediate response which considers seasonality, anomalies, and outliers to form the best forecast. We've also added why questions in Q, so you can dig deep and understand past events and trends that impact the forecast. For example, why did sales increase in January of 2022? Q automatically runs correlations on the back end and provides a list of possible explanations with confidence as to why something changed in the data. And you can then drill down further into these causes simply by asking more questions of Q. We've heard from customers how much you want this capability, and I'm really excited that it's available today. So we talked earlier about how we're finding new ways to understand the vastness and complexity of space, like looking at the same nebula in different light spectra. In the same way, the vastness and complexity of data means that you need new tools to turn this ever-expanding universe of information into insights. You need the best price performance. You need the most functionality to support all of your use cases. You need all the tools to scale in order to handle this massive and ever-expanding quantity of data. And you need all of these tools to work together with Zero-ETL, and you need robust governance to give you the right balance between access and control. When you have all of this, you build a complete end-to-end data strategy that covers all of your data types, your user needs, and your workloads. AWS is the best place to do this. We're investing across the entire data journey, from ingesting, storing, and querying data to analyzing, visualizing, and running machine learning, and producing end-to-end governance to make it easier for customers to unlock the value of their data. It's not surprising that we've worked so hard to understand what exists beyond Earth's atmosphere. For centuries, we've looked up to the stars for guidance, for answers, and used their light to guide us. But in some environments, there is no light. The sea's depths were impenetrable, unknowable, daunting. But still we went. We couldn't resist its lure. Food for the hungry, wealth to the lucky. Adventure, trade, glory, land, power, all possible to those who roamed the waves. And we weren't content to stop there. From the natural beauty of pearls and coral to the tantalizing prospect of salvaging shipwrecks, the bounty beneath the waves was too tempting. We were determined to find a way to explore the ocean's depths. Breathing underwater is one obvious challenge, but not the only one. Pressure is another. Our bodies are designed to withstand 1 atmosphere of pressure. Each 10 feet deeper, 10 meters deeper beneath the surface, pressure increases by 1 atmosphere. You don't have to go far before humans are unable to handle this pressure. We continued to explore the ocean from decks of ships, and we even dove into the shallower depths, but we remained unable to go deep to the midnight zone where there is no sunlight until the invention of this contraption, the bathysphere in the 1930s. This hollow sphere was created from a single casting of top-quality steel. 5-inch thick walls were fitted with fused quartz windows, and it dangled from the ship above by a sturdy steel cable. And in it, we explored depths that no human had ever survived, returning with descriptions of a sea boiling with light from the phosphorescent creatures below the waves. Incredible. Another challenge was simply finding our way around. Humans obviously don't see well underwater, and that limits our ability to explore and to go new places. So where sight failed us, we turned to sound. In the early 1900s, we developed sonar. Now, the earliest versions relied on actual bells affixed below the water. But we quickly moved to electronically generated pings, and finally, we had eyes beneath the waves. Now we could travel the inky depths, confident in our ability to navigate securely. The deep ocean holds challenges and promises for us still. We've mapped out the surface of the moon, but less than 30% of the ocean floor. We have so much left to learn. But with the right equipment and protections, we can continue to explore the ocean's mysteries securely and with confidence. And the same is true for modern IT. The safety and security, the protection of your data and apps are prerequisites for the confidence needed for the digital transformation so many companies are undergoing. With a strong core of protection and the ability to see what's happening around you, that's when you have the confidence to go far and deep, to be pioneers. When we talk to customers and ask why they've chosen AWS, one of the biggest reasons is the security of their apps and their data on AWS is materially better than in their own on-premises infrastructure or in any other cloud. First, security is the central pillar around which AWS infrastructure and services are designed and managed. It's been our top priority since the very beginning of AWS, when we designed for the most security-conscious customers, including healthcare, banks, and government agencies. Our infrastructure is monitored 24/7, offers multiple fault isolation capabilities to improve resilience, and allows encryption in all of the data flowing across the AWS network before it leaves our secured facilities. And today, AWS is recognized as a highly secure environment, passing the highest scrutiny. Now, a good example of this just came in last month. The Options Clearing Corp, OCC, serves as the central clearing warehouse for all listed equity options traded in the United States. They're part of the central nervous system of the financial markets. The OCC will be moving its core workloads to the cloud, enabled by the SEC recently issuing a notice of no objection. This is a once-in-a-generation technology decision. We are really excited that the OCC is running this mission-critical applications on AWS. The second reason why customers rely on AWS for security is that builders no longer have to trade off security with speed. On AWS, building securely is the path of least resistance. As you're building your app, services like Code Whisperer or Code Guru use machine learning to help you write secure code from the start, improving your security posture even as you move quickly. Third is the wide range of security-focused services that we've built to help you identify, remediate, and remove vulnerabilities and threats in your applications. This gives you the confidence to keep building and to keep exploring. You can't go 1,000 feet down with just a snorkel and a mask. You want powerful capabilities designed and built by experts, which encode years of experience, knowledge, and best practices, all available at your fingertips. AWS services like Inspector, Macy, Security Hub, Shield, and GuardDuty. We built GuardDuty to help make detecting and responding to security threats quick and easy. We've taken our security learnings and your feedback to build machine learning models that intelligently and continuously monitor and identify hard-to-detect threats, often a lot faster than other security products. GuardDuty then delivers security findings in detailed ways so that you can remediate them. Tens of thousands of customers using GuardDuty already, including 85% of AWS's largest 2,000 customers. And it easily scales to meet the needs of any organization, whether you have 2 accounts in AWS or thousands. If you aren't using GuardDuty, you might ask yourself, why not? And we're continuing to innovate here. One area where we think we can help is containers. So containers are increasingly popular for compute because they let you move fast and be more portable. You need the right tools to keep them secure. That's why earlier this year, we launched GuardDuty EKS protection to detect threats inside your managed Kubernetes environments on EKS, like malicious actors trying to log into your EKS cluster. This helps you see what's going on outside your containers, but it's also really important to see what's going on inside the container. You want to know if there are suspicious scripts being executed in the container and to be alerted so that you can respond before it can cause damage. So today, I'm really pleased to announce a new capability of GuardDuty that adds container runtime threat detection. Now GuardDuty will help detect threats from software running inside your container by monitoring operating system level behavior in the container itself, such as file access, process execution, and network connections. It can detect an attempt to access underlying compute nodes and obtain an instance credentials, or identify a container that's trying to communicate with the malicious actor's command and control server. The fourth reason that customers are more secure on AWS is that we provide access to a broad marketplace with thousands of third-party solutions who integrate deeply into AWS. No one explores 11 kilometers down in the Marianas Trench alone. You need a full set of capabilities to monitor pressure, depth, temperature, and oxygen levels. And the same is true with security. Our AWS marketplace today includes a myriad of security solutions, including application security, data protection, perimeter protection, compliance, identity and access controls, and more. Companies usually employ a wide range of these services and tools to help improve their security posture. These tools generate log and security data that help you monitor and understand your security posture. Partners like CrowdStrike providing endpoint data, Trend Micro monitoring cloud workload activity, or Tanium providing IT asset inventory data. All are crucial in monitoring your security, and all work closely with AWS security offerings. Now, all of these sources produce logs in their own unique, frequently incompatible formats. So to help define a standard data format for all of the security data, we recently co-founded the Open Cybersecurity Schema Framework, OCSF. It includes a vendor-agnostic data taxonomy that normalizes security log and event data across a wide range of products, services, and open source code. But trying to gather and analyze all this data is difficult. Like using sonar to peer into the depths of the ocean, you want to be able to see into the depths of the data to identify threats and to mitigate them before they can cause harm. Security data is usually scattered across your environment from applications, firewalls, and identity providers. To uncover insights like coordinated malicious activity aimed at your business, you have to collect and aggregate all of this data, make it accessible to all of the analytics tools that you use to support threat detection, investigation, and incident response. And then keep the data pipelines updated and continuously do that as events evolve. What this adds up to is that what you really want is a tool that makes it easy to store, to analyze, to understand trends, and to generate insights from security data. So that's why today I'm absolutely thrilled to announce the preview of Amazon Security Lake. Security Lake is a data lake that makes it easy for security teams to automatically collect, to combine, and to analyze security data at petabyte scale. Security Lake is optimized for security data. You can now automatically build a security data lake with just a few clicks. It gives you visibility into all of your security data and improves the performance of workloads, of applications, and of data. But before you can collect your security data, you want it in a common format for analysis. And Amazon Security Lake is the first data lake that supports the OCSF standard that I introduced earlier. Security Lake automatically collects and aggregates security data from partner solutions like Cisco, CrowdStrike, and Palo Alto Networks, as well as from more than 50 security tools integrated into the Security Hub. Security Lake also normalizes AWS logs into OCSF, including VPC flow logs, CloudTrail management events, Route 53 resolver query logs, and more. And you can add your own sources of data, such as your internal application or network infrastructure logs. Security Lake manages your security data lifecycle and automatically handles retention. Now that you have all of your security data collected and stored in a common format, you need a way to analyze it and generate insights. And Security Lake helps with this as well. You can query the data with Athena, OpenSearch, SageMaker, as well as a number of third-party solutions like Splunk, IBM QRadar, Sumo Logic, and VMware Cloud Health, amongst others. We realize security is a team sport. So for example, now you can run a query using Amazon Athena across a variety of data sets collected over the past year, including VPC flow logs and DNS queries logs from AWS, firewall logs from Cisco, and authentication logs from Okta, to get a clear view of all the users using one particular AWS bucket. And then to determine if any of those users have connected to a malicious site and potentially compromising your data. We look forward to seeing how you're going to use Amazon Security Lake to improve your security posture, to reduce the time to resolve security issues, and to simplify the lives of your security and your operations teams. So just like these deep sea explorers who found new ways to go where no one had gone before and to discover how to navigate with confidence, we're going to continue to help you explore opportunities around you securely. Now, securing the unknown always comes with challenges, but there's a spectrum. Some explorations are gentle wanderings in new environments, and others are a little more extreme. It's hard to imagine a more intense environment than Antarctica, the coldest, windiest, driest continent on Earth. One of the most famous stories of exploration takes place here, a race, two teams fighting to claim the title first to the South Pole. Captain Robert F. Scott, a celebrated explorer, in September of 1910, he announces his intent to be the first to plant a flag at the South Pole. On the other side, Roald Amundsen, who surprises the world by announcing his intent to race Scott to the pole. The same grueling journey, two different preparations. To haul gear and rations through the deep snow, Scott relies primarily on Siberian ponies. Unfortunately, their narrow hooves plunge into the deep snow with each step, and sweat turns to sheets of ice along their back. Their health falters, and they perish in the frigid cold. Amundsen brings a large and exquisitely trained team of dogs to pull the sledges. Unlike the ponies, the dogs are incredibly well-suited for the work. They dash across the powdery snow without sinking in and burrow into the snow to sleep warmly at night without blankets or shelter. After the ponies perish, Scott's team trudges hundreds of miles, pulling sledges much of the way. The intense cold dries out the snow, causing a sandy feel that grabs at the sledge runners, making the job even more exhausting. Amundsen teams are expert skiers. They glide along as the dogs pull the sledges, and the sandy snow doesn't slow them down. Amundsen has learned to wet a piece of seal skin and rub it along the sledge runners, creating a casing of ice that glides over even the driest snow. Extreme conditions make even seemingly small differences incredibly impactful. For our two explorers, a decision about metal cans leads to drastically different results. As Scott's team travels deeper into the interior, their fuel cans are lighter than expected. The screw-top containers that they're using don't seal sufficiently, causing the fuel to evaporate. This is a critical error in the barren wilderness. In time, the team lacks the fuel to warm themselves, to cook food, or eventually to melt water. Amundsen is aware of the evaporation issue, and he includes in his team a tinsmith, Ludwig Hansen, who hand forms meticulously sealed containers. And they work so well that one of these containers is found 50 years later, still full. Amundsen's choices pay off. His team reaches the South Pole a full 33 days before Scott, and the entire team makes it back to base camp victorious. Their place in the history books is secure. When Scott's team finally reaches the pole, they are confronted by Amundsen's flag. They've trekked over 800 miles, only to turn back in defeat. Tragically, 5 men, including Scott, perished trying to make it back to base camp. To honor the heroic efforts of both intrepid explorers, the U.S. research station at the South Pole is named the Amundsen-Scott South Pole Station. This story is a stark example of the fact that when you face extreme environments, good enough simply isn't good enough. Your choices must be specifically tuned and powerful enough to overcome extreme challenges. Dogs versus ponies, skiing versus walking, soldered versus screw top. And the same is true for the millions of customers building on AWS who require the broadest set of services and capabilities, especially for the extreme workloads where performance matters. Formula One's racing car design requires simulations involving over 550 million data points to model the aerodynamic wake of their cars. On AWS, F1 was able to reduce the simulation runtime by 70%, from 60 hours down to 12, creating a new car with less than half of the turbulent airflow. Epic Games' Fortnite supports hundreds of millions of players, with up to 13 million players interacting in real time together. This creates a workload for a fleet of tens of thousands of game servers with the best performing compute and networking capabilities to provide a low latency experience. And the Nielsen Company leverages AWS to process hundreds of billions of advertising measurement events every day. On AWS, they're able to scale their infrastructure with the right compute to support this demand. This performance and agility are no accident. It's a result of deep, long-term investment on behalf of customers. AWS has been optimizing and innovating compute and storage and networking infrastructure services to support all of your workloads for over 16 years. And these needs are why today, AWS has more than 600 compute instances. 600 different instance types so you can find exactly the right combination of resources for all of your extremes. A number of years ago, we realized that to push the performance envelope, we had to push all the way down to the silicon. So since then, our custom chips have been a big differentiator for AWS. Others have taken notice and even announced chips that haven't really come out yet, but none are even close to where AWS already is today. First, we completely invented virtualization with the Nitro system, which offloads storage and networking to specialized chips, so all of a server CPU is dedicated to running your workloads, giving you performance indistinguishable from bare metal, but at a lower price. But we didn't stop there. We designed our own processors, starting with Graviton, which today delivers the best end-to-end performance and energy efficiency. We're now on our 3rd generation of processors with AWS Graviton3, and Graviton3-based instances are 25% faster than Graviton2 and use up to 60% less energy than comparable EC2 instances. Customers of every size have adopted Graviton, and they're achieving up to 40% better price performance simply by shifting their workloads to Graviton instances. For example, DirecTV chose Graviton3 instances, reducing costs by 20% and latency by up to 50%. And they're able to scale up for daily traffic spikes and scale down when it's not needed, all with performance, with security, and with availability for their fleet. So today we have over 100 different Graviton instances, and we're far from done. Last night, Peter DeSantis announced the new C7gn instance, powered by Graviton3, which has over 200 gigabits per second network bandwidth and up to 50% higher packet processing over existing network-optimized instances. This makes C7gn ideal for network-intense workloads and things like analytics, databases, and network appliances. And Graviton isn't only powering EC2, it's also driving better price performance for many of our managed services. For example, with Fargate, you can see up to 40% better price performance. Now, there are also a growing number of workloads that require extreme performance. One of them is machine learning. There are two main types of machine learning workloads, training and inference. Training uses create new models, and inference uses those models to generate predictions. And these models are growing exponentially in size as researchers and businesses push the boundaries of what's possible. Just 3 years ago, the state-of-the-art of deep learning models included millions of parameters. And today, they've grown to hundreds of billions of parameters. That's a 500 times increase. The growth in model size is expanding the time required to train them from days to weeks, even months in some cases. And this is driving exponential growth in training costs. And that's why we built our Trainium chips to deliver the highest performance for machine learning training. Trn1, our Trainium-based instance, delivers the best price performance for training deep learning models in the cloud, reducing the cost to train by up to 50% compared to similar GPU-based instances. Speaking of extremes, Trn1 delivers up to 800 gigabits per second of network bandwidth, so you can easily train large-scale models across multiple servers, reducing training times back down from months to weeks or even days. So once you've trained your ML model, using it to generate predictions in real time can also require extreme performance. That's why we built Inf1 Instances, powered by our Inferentia chip to deliver low latency, low cost inference. Inf1 delivers up to 70% lower cost per inference than comparable GPU-based EC2 instances. For example, Qualtrics builds products that use machine learning to analyze millions of data points originating from surveys, from call center interactions, and from social media. Using model compression on AWS Inferentia, they doubled their inference throughput while reducing cost per inference by 40%. Now, Inf1 is great for small to medium complexity models, but for larger models, customers have often relied on more powerful instances that don't actually have the optimal resource configuration for their inference workloads. Just like Amundsen choosing dogs over ponies, you want to choose the solution that's best fit for your specific needs, which is why today I'm excited to announce the preview of our Inf2 instance powered by our new Inferentia 2 chip. Customers can deploy a 175 billion parameter model for inference on a single Inf2 instance with 4 times higher throughput and 1/10 the latency of Inf1 instances. Now, another area that's been driving technology advancements for decades is high-performance computing. HPC is used to tackle some of the world's biggest challenges, from drug discovery to energy utilization and electronic design automation. HPC workloads demand large-scale computation to solve complex problems with massive amounts of data, of storage, and they need high-speed networking distributed across a large number of instances. Just last month, researchers from the Dana-Farber Cancer Institute worked with AWS to spin up a supercomputer with 5.6 million Intel Xeon scalable cores to perform drug discovery experiments. And then they spun it back down when they were done. It was one of the just amazing, largest high-performance and parallel computing efforts ever conducted on any cloud. And it enabled them to process 48 times more target drug molecules for treating specific cancers than ever before. The scale of the cloud is redefining HPC. And it's resulting in applications and innovations that are nothing short of game-changing. And customers like Dana-Farber are at the forefront. When we talk to our HPC customers, we hear 2 things generally. First, they need infrastructure tailored to their exact workloads and performance needs. Any mismatch can result in excessive costs or prohibitively long job times. Second, they need tools that are easy to use so that they can spend more time experimenting and less time managing infrastructure. At AWS, we have a complete set of HPC capabilities, from job orchestration and cluster management to a file system that scales to millions of IOPS. But you can't create a performant, cost-effective foundation for HPC without a range of instances optimized for each specific workload. So just like the choices made by Scott and Amundsen had major consequences in Antarctica, the extreme scale of HPC means that even seemingly small differences in resources can carry high stakes for performance, for cost, and for speed. HPC workloads typically can either be compute intensive, compute and networking intensive, or data and memory intensive. Compute-hungry workloads include weather forecasting, computational fluid dynamics, and financial options pricing. To help with this, we have the HPC 6A instance, which delivers up to 65% better price performance over comparable compute-optimized x86-based instances, and provides support for the broadest set of ISV solutions. So depending on size and complexity, many of these compute-intensive workloads also require more network performance. And for these workloads, last night Peter announced the new HPC 7G instances, powered by Graviton3 and Elastic Fabric Adapter. The 7G offers even more compute and networking capabilities to meet your demands and your more extreme workloads. Now, the third type of HPC workload requires modeling the performance of complex structures, things like wind turbines, concrete buildings, industrial equipment. Without enough data and memory, these models can take days or weeks to run in a cost-effective way. And so for these type of workloads, again, good enough simply isn't good enough. So today, we're announcing the new HPC 6ID instances. 6ID instances are designed to deliver leading price performance for data and memory-intensive HPC workloads with higher memory bandwidth per core, faster local SSD storage, and enhanced networking with Elastic Fabric Adapter. With 6A, 7G, and 6ID, AWS offers HPC instances with the best price performance for each of your specific workloads. Now, one customer who's driving their digital transformation on AWS with everything from HPC to real-time simulations and IoT is Siemens. To tell us more about their journey, please let's welcome Cedrik Neike, CEO for Siemens Digital Industries.
So thank you, Adam, and it's actually great to be here with you today. There is something which, if I think about it, Adam spoke about the vastness of space. I mean, he really talked about the vastness of space. And I have to tell you, as a kid, I actually wanted to go to space. But what if? What if I could tell you, all of you could go to space? Would you do it? Yes? Someday, yeah, no, I don't know. You can. It's wrong that you cannot go to space. Why? Because Siemens and AWS, we have enabled a solution. And the solution is called Space Perspective. It's a startup which is revolutionizing space travel. So instead of sending a rocket to space, they take a capsule, they put a huge balloon, and fly you to the edge of space. It's cheaper, it's safer, it's carbon neutral. So how do we do this? How do we enable this? We combined the Siemens leading testing and design software with the AWS cloud software. Now a startup can actually virtually design, test, optimize a spaceship. And for example, they use this high performance compute from AWS with our SimCenter from Siemens, which is actually this computational fluid dynamic modeling. This used to take weeks. We can do it now in 8 hours. What does that mean? It might be able for you to go to space. You might be able to go to space. So check them out, try to book a seat, but I'm not here to talk to you about space travel today. My name's Cedrik Neike. I actually work for Siemens. I run the industrial business. And Siemens, we're a leader in infrastructure, industry, and healthcare. Actually, 92% of all Fortune 500 companies are using our software. So you may or may not realize it, but we have an impact on your life. So I don't know, any one of you which ever came to Las Vegas with their car? So if you came with a car, it was probably designed using a Siemens software. 24 out of the 25 biggest car manufacturers are using our software. But not only that, it was probably not only designed, it was probably also produced using Siemens automation. We're a leader in industrial automation, which means that on the shop floor, every third machine has a Siemens controller. So why is that important? Because we want to do something which is called dream it and make it. You dream it, and we help you make it. So we can do this for infrastructure, for healthcare. We're actually helping you build better trains, better buildings, better healthcare. And we've been doing this for more than 175 years. Now comes the questions. Why are we working with AWS? Why am I here? Because we want to work with you to shape the next industrial revolution. And this revolution needs to be much, much more environmentally sustainable. It needs to be also much, much more socially responsible. You have a lot of good ideas. We need to help you scale them. So what is AWS and Siemens doing to help you scale good ideas? 3 things. So step 1, first step. We take our amazing Siemens industrial software, which was mainly available for large companies, and thanks to AWS, we're putting it into the cloud. So anyone and everyone can use it. So that's the first step. What type of software is it? CAD software, it's simulation software, it's actually planning and collaboration software. We put it into the cloud. Why? Because we want to make it available as a service, right? This amazing tech needs to be not only for big companies, but also for startups or actually small companies. So in the past, only big shots like NASA had the tools to actually build a spaceship to take you to space. Now we leveled the playing field. So that's the first one. We make our industrial software available to you. If you're a startup, if you're a system integrator, use it. That's the first thing. What's the second thing? The second thing is what Adam talked about is there's huge amount of data in my space, in the industrial space, vast amount of data which is locked in the industrial space, and we need to unlock it. This data is actually never used. I'll give you an example. Think about it. This is just one of our factories. A modern factory produces 2,200 terabytes of data per month, so-called OT, operational technology. It sits in the machine. That's roughly the equivalent of 500,000 Netflix movies. And you know what? We need to make sure that we can extract that data and we can make production processes better because of that data. Because once the data was trapped in the machine, we could not use it. We want to add value. We use something called an accelerator to do it, Siemens accelerator to do it. And we're offering this thanks to AWS in the cloud. So let me give you an example of what you could do with it. So this is Northvolt. You go to Scandinavia. This is a Scandinavian startup, has billions of funding. They want to transform the move towards e-mobility. They want to build the next generation of battery cells. They want to do this with 100% renewable energy. They want to do it with at least 50% of recycled materials. And they have big dreams. They will build 150 gigawatt hours of batteries annually by 2030. That's a lot of gigafactories. Each of these factories need to collect and utilize hundreds of thousands of data points every second, which are produced in the machines, and they need to take it out of the shop floor, and they use something called a cloud factory module. So what's the technology behind this? So all these machines push their data into Kinesis data streams. So multiple AWS services are used to extract, transform, manage the data flow into hot and cold data paths, where it can be used to tasks like simulation, machine learning, product traceability, near real-time monitoring, and manufacturing. So this allows Northvolt to be extremely flexible so they can connect all of their factories easily using AWS and Siemens. The results, every battery produced is better and more sustainable than the previous one. And this can be applied to vaccines, to food production, to car production, to anything. So that's the second step. What's the third step? The third step is not only we put software into the cloud, you should use it. Second one, we make OT available, you should harvest this. The third step, we need to make it easier and faster for everyone to use it. How? For this, we use a low-code, no-code capability from Mendix, which is running on AWS. Mendix is the #1 low-code solution with over 200,000 developers, and it's available on the AWS marketplace. Mendix enables anyone to build any application on any business problems, from mission-critical solutions to actually digital experiences, from banking, insurance, retail, and public sector. you can develop using Mendix 10 times faster using 70% less resources. There's a wide range of actually AWS connectors which are easy to be utilized, which makes it easy to utilize the AWS services like Amazon DynamoDB or Amazon Rekognition. So if you can just check it out, I'm sure it can help you. So I'm going to sum it up. What do I want you to remember? AWS, Siemens, and you, we're coming together to shape the next industrial revolution. How? A, we take our software into the cloud, making it available for everyone. Use this powerful software to solve your business problem. First step. Second step, we're actually enabling you to tap into this vast amount of operational data. You should unleash the value of that data. And the third step, we want you to, all of you builders, to scale your ideas. We want to make it easier and faster to build application using this Mendix low-code capability. So if I bring all of this together, AWS, Siemens, and you, we can help find solution to dream and make a better world. Thank you.
Thank you, Cedrik.
Adam.
Such a great partnership working together and all of the innovative things that you're driving and being able to do them together in AWS. It's really inspiring. Thank you for the partnership.
Thank you, Adam.
All right. Siemens is one of many companies using AWS to power simulations. Now, simulations are a type of HPC that's becoming more and more prevalent as real-world scenarios are just too expensive, time-consuming, dangerous, or flat-out impossible to build and test live. Simulation workloads are massive and highly complex, and they use specialty software to spread the computation out across multiple compute instances. Conventional simulations, like weather forecasting, can be supported with this type of scale-out processing. But there's an emerging, more complex type of simulation called spatial simulations. Spatial simulations model how high-level entities like people, objects, how they all act within a multidimensional environment. This is a more complex situation than a classical simulation and requires millions and millions of real-time interactions. For example, spatial simulations can be used to model an urban city like London or LA to help improve traffic flow, safety, to assess the impact of new housing projects and developments, and to optimize emergency plans for disaster response. To do this, the simulations need to deal with millions of people, cars, traffic lights, railways, bridges, and more, each with its own associated behaviors and properties. So like an actual city, this simulation is an expansive world all unto itself. And today, if you're thinking about modeling spatial systems, it makes sense to use a 3D engine. 3D engines are well suited for virtual environments because they can model these high-level behaviors while still supporting fine-grained details. But 3D engines were never designed for scaling out to multiple compute nodes, and so developers are left with a choice. They can either limit the size of their simulation and run it on a single piece of hardware, or they can spend a lot of time and effort toiling over complex, messy systems to scale out and have the simulation run on the 3D engine. So we knew this was a trade-off that customers should not have to make. So today, I'm very excited to announce AWS SimSpace Weaver, a new managed service for running large-scale spatial simulations. With SimSpace Weaver, you can run large-scale simulations without being constrained by a single piece of hardware or having to manage the underlying compute, memory, or networking infrastructure. And this means that developers can spend more time building and understanding their simulations and less time deploying and scaling them. Once you've designed your simulation in a 3D engine, you upload your performance code and then configure a job in just a few clicks. Behind the scenes, SimSpace Weaver automatically distributes spatial simulation across the 3D engine, spreading the areas of the world across multiple EC2 instances. So SimSpace Weaver enables objects to move seamlessly from one instance to another as they move across different areas of the simulation. enabling expansive worlds without sacrificing the details of 3D objects with real-time interactions. SimSpace Weaver integrates with the most popular 3D engines like Unreal Engine, Unity, and even custom simulation engines via the SimSpace SDK. With SimSpace Weaver, you can stay focused on building your simulation code and creating the content to fill these expansive worlds instead of managing infrastructure. Whether you're using the power of new HPC instances or scaling simulations with SimSpace Weaver, we're looking forward to supporting all of your simulations at scale, continuing to help you push the boundaries of what's possible. Just like our famous explorers, you need powerful and specialized tools to run each of your application workloads. So whether it's the best price performance for general purpose compute with Graviton, faster and cheaper training and inference with ML, with Trainium and Inferentia, or performant, easy to use HPC tools to do simulation, we are going to keep on innovating to help support all of your extremes. Now, there's one other area of exploration that's even more boundless than space, more challenging than the ocean, more extreme than the Antarctic. I'm talking about the world of imagination. Imagination is a world we all can explore. A child picks up a stick and it becomes a wizard's wand in the realm of imagination, a pirate's spyglass, a sword. The realm of imagination is one of total possibility. But how do we actually explore the realm of imagination? Cognitive scientists have shown that engaging our imagination actually lights up the same parts of the brain that we use to perceive real-life experiences. So it makes sense that exploring our imagination can mean taking something we know and then selectively editing it, removing certain constraints. Take, for example, J.M. Barrie's Peter Pan, an enduring tale of the boy who never grows up. It's clearly an impossible idea. We all understand the realities of time's passage. But the fantasy becomes vivid in our minds precisely because it's built on our own experiences of childhood. We tap into those memories, and it brings that emotional resonance to the story. Of course, it's not the only way that we explore our imagination. Sometimes we combine disparate elements or situations together, making something entirely new. A great example of this is J.R.R. Tolkien, a medieval languages scholar. Tolkien rifled through the mythologies of various different cultures and civilizations and combined his pickings together into a modern-day mythology far greater than the sum of its parts. Magical rings can be attributed to Norse myths. Rivendell, the elves' home, was inspired by Celtic folktales. Gandalf is often thought to be inspired by the god Odin and Smaug the dragon from many different cultures' mythologies. In the world of Tolkien's imagination, he fused these disparate symbols into powerful and enduring series of tales that have inspired so many. Finally, exploring the imagination is often a collaborative effort. Preschoolers play spaceship or house, reacting to one another as the game progresses. People come together and generate better ideas than any one person could. Creativity thrives in the company of other imaginative explorers. And now, with online immersive games and virtual reality, we can literally go to imaginary worlds, becoming different characters, interacting with each other and sharing adventures. Technology has changed how we can explore our imagination together. We are no longer restricted by proximity to one another. Now the world is one neighborhood and we can all come out to play. Now we know AWS customers are exploring their imaginations every single day. And we know this because you invite us, in turn, to help turn your dreams into reality. New ways to remove constraints, to make sense of disparate information, and to collaborate to enable even more innovation. And it's our job to deliver on that. Let's start with the first one, removing constraints. Now, this has been a focus of the cloud from the very beginning, as we enabled customers to grow and shrink their infrastructure instantly, securely, reliably. Now customers want to remove constraints in important business functions, such as contact centers. Contact centers used to be expensive to manage and inflexible. You had to invest in complex proprietary hardware and systems that locked you into upfront pricing that couldn't easily scale. Amazon Connect changed this. Setting up a scalable, cost-effective contact center in the cloud is now as easy as a few clicks in the AWS console, and agents can begin taking calls in minutes. You can onboard agents quickly from any location, scale up and down, leverage out-of-the-box machine learning features, and only pay for the time that agents are interacting with customers. And the impact for our customers has been amazing. Today, tens of thousands of customers use Connect to support more than 10 million interactions per day. News Corp deployed Connect in just 3 weeks. Convoy improved the percentage of escalation calls that are answered in less than 1 minute by 50%. And Priceline enabled more than 1,000 agents to work from home overnight. The sophisticated capabilities of Connect help you provide great customer service at scale, empower agents, and operate more efficiently. And today, I'm excited to announce 3 new capabilities for Connect to help remove even more constraints. First, we're introducing new forecasting, capacity planning, and scheduling capabilities to help contact center managers. Very helpful. To help them optimize agent schedules and ensure that they have the right agents at the right time. Second, we're previewing new agent performance management capabilities in Contact Lens, Connect's real-time analytics. These reduce the time that contact center managers spend identifying performance issues and helping to coach agents. And third is a new user interface that guides agents through customer interactions so they can resolve issues even faster. Connect is a great example of how the cloud is removing constraints to reimagine business challenges like delivering better customer service. Now, there are many other areas in which customers have been experiencing difficult problems and where they'd like us to help remove constraints. One is supply chain. Supply chains involve coordinating complex global networks of suppliers, parts, manufacturing sites, distribution facilities, and transportation providers, all while trying to deliver the right goods at the right time at the lowest cost. And the last 2 years have highlighted the importance of supply chain resilience. From baby formula shortages to ships circling ports unable to unload, the disruptions have been widespread and deeply felt. Addressing supply chain issues around inventory is especially critical. Businesses need to plan for supply chain disruptions, respond rapidly to ensure the right levels of inventory are available, and keep costs manageable. Managing inventory requires accurate and up-to-date visibility into your supply chains. And to get a complete view of inventory and of your supply chain, you need to build custom integrations to collect and process data across a vast array of ERPs and supply chain management systems. Now, this can introduce expensive consulting engagements, long-term development cycles, complex ongoing maintenance, and the scale and the complexity of the data makes it really difficult to analyze and reveal problems in real time, forcing you to make decisions on outdated or inaccurate information. Even when you have identified the most impactful problems, you still need to figure out the best actions to take to solve issues, like rebalancing your inventory quickly. For example, you might discover a potential stockout at your facility, but without a complete picture of your supply chain network, you have no idea which facilities might be able to help transfer inventory. So you might resort to a bunch of emails or calls to other facilities to resolve the issue. Now, over the past 25 years, Amazon has tackled many of these problems and answered a lot of these questions for ourselves. And many AWS customers have asked us whether we could take Amazon supply chain technology and AWS's infrastructure and machine learning to help them with their supply chain. So today, I am thrilled to announce the preview of AWS Supply Chain. AWS Supply Chain is a new cloud application that improves supply chain visibility and delivers actionable insights to help customers mitigate supply chain risks and lower costs. With AWS Supply Chain, you get a unified view of your supply chain data, ML-powered insights, recommended actions, and built-in collaboration capabilities so you can react quickly to unexpected issues. Let me show you how it works. First, with just a few clicks, you connect your supply chain data from SAP, EDI, or other sources like warehouse management or order management systems. Then AWS Supply Chain automatically sets up a data lake using ML models that have been pre-trained to understand, extract, and transform disparate, incompatible data into a unified data model. Since you don't have to manually map data fields, this can be done in days versus months. AWS Supply Chain then contextualizes that information in a real-time visual map. And this map shows overall inventory health across your supply chain network. Let's say you are a produce inventory manager at a grocery chain, and you can click onto any of these locations and drill down and look at the view of current Honeycrisp apples inventory on hand, in transit, or potentially at risk at a particular location. From here, you can get started by creating a watch list, and that's going to automatically alert you when there's a potential stockout or overstock of apples in the Southeast. AWS Supply Chain uses machine learning to predict lead times based on your prior purchase orders, on shipping history, on product attributes, on vendors, and on locations to highlight potential risks. Here you see a new stockout risk for Honeycrisp apples in Atlanta. So you can go ahead and move that to review in order to look at the details. Supply Chain automatically evaluates, ranks, and shows various rebalancing options that you could take. Recommendations are scored by the percentage of risk resolved, by the distance between facilities, and even by the sustainability impact. From here, you can confirm the best recommended action is to move inventory from Alabama to Atlanta to avoid a stockout. And you can kick off a chat with the Alabama inventory manager. All of the relevant information about the risk and recommended action is automatically shared, so you can both agree on the inventory rebalancing decision and make the change in the system of record, helping you to avoid errors and delays. AWS Supply Chain helps you mitigate risk and lower cost by giving you a unified view of your supply chain and surfacing the best actionable insights, all with pay-as-you-go pricing and no upfront licensing fees. And this is just the beginning. We're going to continue to invest here and work to solve your hardest supply chain problems. But removing supply chain problems isn't the only issue that our customers face, nor is removing constraints. Like Tolkien's woven tales, customers also want to bring disparate elements together to develop something greater than the sum of its parts. They're discovering that the cloud is a great way to do it. One common problem facing companies across a variety of industries, including financial services, healthcare, and advertising, is collaborating on shared data sets while still protecting the underlying raw data. Data clean rooms, protected environments where multiple parties can analyze combined data without ever exposing the raw data, have emerged as a solution. But clean rooms are hard to build. Their complex requirements take months to develop. And once you've built a clean room, you have to continuously update the data, all the while meeting requests for new collaborators and data types. Imagine if it could just be easier. Well, today I'm excited to announce AWS Clean Rooms. AWS Clean Rooms is a new service that allows companies and their business partners to securely analyze and collaborate on data sets without sharing or revealing the underlying data. The service makes it easy to create clean rooms in minutes. You don't need to move data out of AWS or load it into another external tool. AWS Clean Rooms just reads data where it lies and applies the right restrictions to help you maintain control over your data with an advanced set of privacy-enhancing controls. By analyzing your combined data sets, you can generate insights to improve your understanding of your own customers. And AWS Clean Rooms includes cryptographic computing tools that lets you keep your data encrypted even as queries are processed. Let's look at an example. One industry that relies heavily on data for personalization, measurement, and creating new experiences is advertising. For example, I have data in my loyalty program, and you have data on ad clicking behavior. And we can use AWS Clean Rooms together to bring it together and generate new insights that neither one of us could achieve on our own. With these insights, we can produce even more relevant ads while maintaining privacy for everyone. To get started, brands and media publishers use the Clean Room console or the API, and they set up a clean room and start collaborating with other companies in just a few clicks. So instead of spending months of development time to customize the types of queries and restrictions you need to allow partners to run in clean rooms with you, you have built-in analysis that helps you define how data can be joined and analyzed for use cases like ad measurements or attribution. Now, another challenge that companies face in this situation is that their data relating to any one customer is spread across a range of channels and data stores, and it's really challenging to link it all together to get a single view of any one customer so you can understand that customer and take relevant action. So next year, we're going to be adding identity resolution, which helps companies match and resolve disparate records into a single complete view of a customer without the need to build and maintain complex solutions or to share the underlying data. So together, AWS Clean Rooms and identity resolution is going to make it easier to incorporate more insights about customers and take relevant, targeted actions while protecting customer privacy. Another area where the cloud is helping companies to bring data together is healthcare. In fact, in this area, it's even changing lives. From drug discoveries to insurance efficiencies and hospital bed allocations, healthcare and life sciences organizations have an unprecedented opportunity now to use technology to reimagine healthcare. Like many of you, I've had people I care about impacted by cancer. And I think we're all aware of the incredible toll that cancer treatments take on patients. One company that's working to change that is here with us today. So I'm really honored to invite on stage the CEO of a groundbreaking startup to tell you about what happened when they began to imagine. So please welcome to the stage Liz Homans, CEO of Lyell Immunopharma.
Thank you, Adam. Lyell is so excited and so proud to be here today. Good morning, everyone. I'm going to kick us off with some interesting, if sobering, facts about cancer. First one is that 40 out of 100 of us will actually get cancer in our lifetimes. That means, just statistically based on the size of this room, 2,000 of us will get cancer. On the flip side, 250 of us are already cancer survivors. But even if you're able to avoid getting the disease in your lifetime, you'll probably still have intimate knowledge of it, because 90% of us will take care of a loved one with cancer at some point in our life. Now, the biotechnology industry is making progress in developing new therapies for cancer. And cell therapy is the next frontier. And what that means is we use your body's immune cells to make new, effective medicines. Now, you may be surprised to hear that some blood cancers, like lymphoma, can be completely cured with one dose of cell therapy. Now, that's something that was completely unimaginable 10 or 15 years ago. The problem is that most cancers aren't blood cancers. In fact, 90% of all cancers are solid tumor cancers, like liver, lung, colon, and ovarian. And for these types of cancers, cell therapy has not yet been successful. 4 years ago, we founded Lyell to change all of that. Now, I'm going to give you just a 30-second biology lesson here. You might be surprised to learn that when your T cells are trying to fight off a solid tumor, they actually become exhausted, and that is a scientific term. The tumor is so clever that it actually pushes the T cell into this dysfunctional state. It's no longer potent, and it can't actually eradicate the cancer. But at Lyell, we have genetic and epigenetic reprogramming technologies that allow us to endow entire populations of T cells with the ability to resist exhaustion, which means they maintain their functionality, they maintain their potency, and they maintain their cancer-killing ability. And we are testing those T cell therapies in the clinic today. So how does that actually happen? How does that start? Well, it starts with a patient, and that patient gives us their cells. So they're trusting us with their cells. And I think from the patient perspective, it's probably, don't lose my cells or don't mix them up with somebody else's. But from our perspective, it's actually much more complicated. We need to take those cells, we need to transport them across state lines, get them to a manufacturing facility where they're moved around lots of different rooms. We have to apply our reprogramming technologies, then we have to check them once, twice, 3 times, make sure that they adhere to every regulatory spec that we're bound by, package them all up, get them back across state lines, and then reinfuse them into the patient as medicine. So this is an incredibly complex process, and we knew we needed to be able to control all of the details. So we built our own manufacturing facility, the Life manufacturing facility. And given the complexity of the process and just the massive amounts of data that cell therapy generates, we knew that AWS was the obvious choice for a strategic cloud provider. And together, we've implemented digital technologies and cloud infrastructure that really form the backbone of this facility. We believe that the Life facility is the only cell therapy facility to benefit from AWS's deep knowledge of Internet of Things, cloud infrastructure, and advanced analytics. Now, when we first started working with AWS, we knew that we would benefit from the deep resident expertise in the healthcare and life sciences team. But we also got ready access to a broad array of partners. And this really helped accelerate the build of the Life facility because we were able to rapidly integrate multiple complex systems. So I'd like to spend just a minute talking about how we worked with AWS. What you're seeing here is a vastly simplified version of the patient journey. These are all the steps that I discussed earlier. And there's lots of opportunity for variability here. And in our industry, that's just unacceptable. And so we knew that for each step of the way, we had to have visibility. And when I say visibility, what you should hear is data. We needed to know not just where the cells are, but what's happening to them as they go from being exhausted T cells into cancer-killing cells. So how did we do that? It wasn't actually intuitive. And when we started off, we really had to suspend all of our disbelief about how we should build a manufacturing facility, jettison all the preconceived notions and biases. And AWS helped us to do that by guiding us through what they called an art of the possible workshop. And that really guided our development of the facility and our thinking. So thanks to AWS and the deep expertise in Internet of Things, we created a solution on AWS that captures data from all of our enterprise applications, our instruments, our equipment, our bioreactors, and we take all of that data and we can push it to AWS real time. And what that does, it means that we can actually access that data real time, and we can do all of the critical correlative analyses that we need to do to ensure that the manufacturing of the product, the medicine, is actually going the way we need it to, but it also allows us to understand more about the biology of the cells, which is great for cancer. So how does this actually manifest for a Life employee? These could be batch records from medicine that's being manufactured for a patient. And a Life employee can actually monitor that real time on their phone. So they can be at the grocery store, they can be watching movies on the couch, and if something goes wrong with a batch, they'll know, and they can address it immediately. And I know if these were my cells, or if they were my mom's cells, I would be really happy with this level of monitoring and careful decision making. Another way that our work manifests in the Lyell facility is what we call Life Mission Control. And this is a centralized location within the manufacturing facility where we have these giant interactive electronic dashboards. And the teams actually gather here on a daily basis to think through the operations of the facility. They gather when there's a problem, and even if we're just trying to improve a process. And that's because all of the data is quite literally at their fingertips. And not just for the batch that they're working on for today, but a historical one or an engineering one, anything that they need to access in order to improve the process or find a solution. Everything that we've done with AWS was designed to scale us for the future. We're testing our therapies in 4 different solid tumor indications today. But if we're successful, we'll rapidly expand into additional indications. And that means larger trials and ultimately commercialization. And AWS will be with us for every step of the journey. Remember those sobering numbers I shared with you at the beginning of the presentation? Well, if there's one thing that you remember from my talk today, I hope it is that AWS and Lyell are enabling transformative innovation at the intersection of technology and biology. And our goal is nothing less than to turn cancer patients into cancer survivors. Thank you for your time.
So amazing. Thank you so much. It's just incredible to think about how patients' own T cells can be used to eradicate the tumors. And I just can't wait to see what's going to happen next. And we're honored that you're partnering with AWS and we can be part of this journey. Thank you so much, Liz.
Thanks, Adam.
In fact, if you look at the innovation happening in healthcare, so much of it is enabled by the cloud and the ability to drive insights from increasingly complex multimodal health data that's growing exponentially. Over the past several years, we've invested in various different healthcare services to help you make sense of health data, to improve patient care, and to securely store patient records with purpose-built services like Amazon HealthLake, Amazon Comprehend Medical, and Amazon Transcribe Medical. And we're continuing to find new ways that the cloud can advance other areas of healthcare and life sciences. Customers are examining all types of biological data to improve health. They're studying DNA, our biological source code. They're studying RNA, the genetic molecules that help cells to make proteins. And they're also studying how these proteins interact together to improve drug effectiveness. The study of this molecular data is called omics. And that includes familiar areas such as genomics, as well as less known ones like transcriptomics and proteomics. But building systems to process omics data is challenging and often slows scientific discovery. You need a way to store omics data that's cost efficient and easy to access. And you need to scale the compute across millions of biological samples while preserving accuracy and reliability. And you need specialized tools to analyze genetic patterns across populations and to train machine learning models to predict diseases. And all of this data is very personal. So you need to keep it safe, you need to keep it secure, and it has to be compliant, all while enabling researchers still to collaborate and share results. Difficult problem. And that's why today I'm very excited to announce the general availability of Amazon Omics. Omics is a purpose-built service to store, query, analyze, and generate insights from genomic and other omics data. Omics is designed to support large-scale analysis and collaborative research. You can store and analyze genome data for entire populations. Once your data is in omics, it's easy to analyze with services such as Athena and EMR. For example, you could combine the genetics data, I can say this, the genome data of individuals in omics with other medical history from Amazon HealthLake to enable multimodal analysis. and then train machine learning models with SageMaker to predict disease predisposition or the efficacy of a drug. You can also bring your own custom workflow definitions and tools, and Omics will take your scientific analysis and run it with just a few clicks, enabling you to transform biological data into patient-level insights. And Omics comes with built-in capabilities to support your compliance with security requirements, with privacy laws, and with regulations. Omics is HIPAA eligible and has built-in access control and logging so that you always know who has access to your data, when, and where. Now, researchers and data scientists are going to be able to use Omics to help target diseases with even more personalized therapy, modernizing care for years to come. We're proud of the work we're doing with our customers and partners to enable better healthcare solutions. It's such a hugely important area. The future of our customers and partners and what they're imagining is breathtaking. And we're going to keep on investing and innovating alongside of them. So there's one industry that actually most of us come into contact with almost every day, and that's retail. How many times have you ever been in a crowded store and the line to pay is so long that you just want to bail? Have you ever thought to yourself, wow, I wish I could just walk out? And now you can. A few years ago, a group of Amazonians started thinking about how they could make the store experience better. And with a combination of computer vision, sensor data, and deep learning, Just Walk Out technology by Amazon was born. With Just Walk Out technology, a customer can scan their phone when they walk into a store, take what they want, and leave. No standing in lines to check out anymore. But we didn't stop there. We started thinking about the other places where you have to stand in line. So waiting in line to get into a stadium or badging into work. Remember that, badging into work? So this led to Amazon One, a new simple way to identify, enter, and pay with your palm. Yep, your palm. To identify yourself and automatically pay so you can just walk out. Now, you don't even need your phone. You can buy an item or enter a venue with just a wave of your palm. These technologies were first built for Amazon Go and Amazon Fresh stores, but now we're deploying them with customers in lots of different places, like Sainsbury's stores in the UK, stores across airports in the US, and sports venues like the Seattle Seahawks Stadium or Texas A&M University's Kyle Field. And customers are already seeing the impact. For example, the Seattle Mariners have reported that transaction at the Mariners store went up over 3 times. I'm going to say that again, 3 times after installing Just Walk Out technology in Amazon One. We're really encouraged by customers' initial success with Just Walk Out technology in Amazon One. We can't wait to see how even more customers are going to revolutionize the shopping experience. So we've just gone through a few of the examples of how customers are reimagining entire industries and business functions using purpose-built solutions on AWS. They're driving such momentum in this area, and we're going to continue to innovate even more here going forward. So looking at how we explore all of these different realms that we've looked at today teaches us about what it takes to thrive in uncharted territories, to see and then seize opportunities. Customers constantly tell us that this is what they need. The ability to gain insights across vast and complex troves of data. The confidence to go to unfathomable depths, knowing that you're secure enough to withstand the pressure and have the ability to see what's around you. The capabilities to perform in the face of the most extreme conditions. And the imagination to look at the existing and envision unlimited possibilities. We're continuing to hammer on all of these areas, delivering what you need to thrive in any situation. This is the real power of the cloud, how it can help to instill and mature that mindset of exploration, allowing you to transform. Transforming how fast you can innovate, creating environments where people come out with ideas, they try them out, and then iterate quickly. Transforming how we think about failure, removing penalties, freeing people to try bigger, bolder, better things. transforming how you make decisions, putting data at the center of decision making, which is revolutionary for most organizations. Ultimately, transforming culture as your organization becomes more innovative, more agile, more able to make great decisions. We are so passionate about what we do at AWS because we see what you are doing with the cloud. Enterprises look to the cloud to innovate in ways they haven't been able to do before. Entrepreneurs bring their dreams to the cloud and change the future. Governments rely on the cloud to provide critical services to constituents. Financial services and pharmaceuticals, researchers and retailers, freight carriers, phone carriers, NGOs, energy firms, entertainment studios, the list goes on and on and on, all of you transforming your organizations and the world around you with the power of the cloud. Thank you so much to everyone watching, and of course a big thank you to my guests on stage, and a big thank you to the whole AWS team for making this entire week and today possible. We have an amazing reInvent for you this year, so please go out there and explore it. Thank you.